Charlie Gary, welcome to Improvisationally Speaking.
Thanks for having me here.
Yes, you are a manufacturing engineering lead at Planetary Resources, and I've known you personally for a number of years. You came from a career in modeling, and
Yes,
you,
but
yeah,
but not like Marky Mark did for Calvin Klein.
that's right. I should specify. We're not talking about, though you could, we're not talking about modeling clothing or anything. We're talking about literally being a modelist, creating. Well, why don't you tell me what is a modelist?
A model maker is a person who can create a fake anything, and done well, it looks just like the real thing. And it could be the size of a cell phone and meant to run in a wind tunnel at over 5,000 miles per hour, or it could be one-to-one scale. Uh, I've I've helped build models that were airplanes with a where the longest dimension, if it was either wingtip to wingtip or nose to tail on the fuselage, the largest dimension was 29 feet because that's what would fit on the range that they were using to look at the airplane.
Wow.
So it might be the type of model that you see in a museum.
Mm-hmm.
You ever been to the Museum of Flight?
Oh yes, many times.
You ever gone into the Big Red Barn and seen displays of like
The
uh,
big machines, the belts, and all that.
that? And I don't know if it's still there. They used to have a display. It looks like a man, a pilot from the biplane era.
Okay.
And I used to work for one of the guys that helped make that model. That was on display.
No
Uh,
kidding.
they might be water tank models like you see done with ships.
Mm-hmm.
Uh, there's a lot of wind tunnel models that we did for America's Cup yacht racing teams,
Mm-hmm.
and Boeing, their companies that wanted airplane models. We did that. We made a lot of wakeboard molds, and water ski molds, and
Right.
kayak paddle molds.
Gotcha.
Those are all non-uniform 3D organic shapes
Yeah.
that a model maker type of person is used to creating, either a model maker or a mold maker, and not the normal type of machining work.
Got it. So
Uh,
you began there. That was the beginning of your career in the world of in the world that led you to where you are now. And I'm wondering, have you always had an interest in space and the mission of Planetary Resources, or is that something that just kind of came upon you at the time that you got the job?
um, I've always had a passing interest in space. Uh, Not as much as other people. I have not seen every single episode of Star Trek that ever aired on network TV. Uh, I I don't really live or die by what happens out in space like some people do, but I think it's a very interesting field, and it's another area of manufacturing that has allowed me to be extremely creative.
Hmm.
Uh, I'm not, well, we actually do have a display model of a satellite that is actually a satellite. We just don't need it for launch purposes. And when we build a satellite, we build enough parts to make sure that we have plenty of good parts. We don't want to only make just enough of something, because what if we need a replacement part later on down the road?
Right.
We're really behind the eight ball then. So we have a display model that goes to trade shows and seminars or whatever, and it's an actual satellite. It's a functional satellite.
Hmm.
They used it in a radio test when the 2 satellites that we're actually preparing for launch. We're in the midst of other tests, system tests and whatnot. And we're not available for the radio test. We took our display model satellite and took it down to a radar range and a radio test facility. And we were able to perform a viable test.
You had said a moment ago that that this work allows you your creativity more than other work. I'm wondering, how is that so?
The way a lot of satellite parts are designed, they are as small as possible, and they have as many features as you can put on one part. Because you have a finite amount of volume in a satellite that you cannot go beyond. You have weight limits that you cannot go beyond. And for as much as it costs to put a satellite up into space and all the things you want it to do, the amount of stuff that you pack into a satellite is just mind-boggling. When you look at one from the outside, they usually look nice and neatly packaged, but on some bigger satellites, you'll see stuff coming off the sides all over the place because they don't have the same volume restrictions that we do with small satellites. So when they're small, they look really nice and neat, but then as soon as you take the side covers off, it looks like you opened up a tiny transistor radio that has the world's best sound quality. It's just so jam-packed with stuff that everything has to go in a certain way, in a certain order, and there's just no room for not getting it right inside there, otherwise everything else won't fit. And so the things that I have to do in order to make these little tiny parts with all kinds of features from all different directions is it allows me to stretch my creative thinking. It allows me to come up with unique solutions. And the challenge for me is creating something to hold a small part that isn't going to be used to make, say, 100,000 parts or 1,000,000 parts like they would for a high-volume machining operation.
I see.
I might only make 3 or 4 tiny little parts. Or at the very least 3 or 4, usually about 8 or 10, maybe 15 or 20. And so the kind of fixturing that a machinist would make to hold those parts, to do 1,000,000 of them, is going to be very durable, very mass. It will have a lot of mass in order to hold up to a lot of abuse, be very stable during a machining operation. And it's very time consuming, very expensive to do that.
Yeah.
So what I do is I figure out ways to hold these parts in the correct position and do it very quickly, very cheaply, using non-conventional materials like auto body filler that you see at the body shop, or some kind of high-strength epoxy glue, a low-temperature metal that melts at 150 degrees that I can pour into or around a part and finish the machining operations. And in order to get it out, I just go set it on a hot plate for a little while, get it warmed up, and the stuff comes off, and the rest I can brush off or sand off or however I need to get rid of it. But there's a lot of ways to hold a part from manufacturing that are laughed at.
Yeah.
People have done it.
Got it. Charlie, I'm just curious on the background, do you have a background noise behind you somewhere?
Just my computer fan.
Oh, okay. All right. Just wondering. It sounded like it was competing for your own voice, and it made it a little bit spotty. I can hear you fine, but I just thought maybe there was like a washing machine or something. But no, I don't think there is.
Is that any better?
I think so. Thank you very much.
Certainly.
So that sounds really interesting. You kind of take whatever will work, whatever will serve the purpose to create the product that you're trying to create. You will use material from anywhere and everywhere that you might think of in order to achieve that. Is that true?
That's true. The places I go to get material for making parts are not the normal places people will go. I go places like Fred Meyer, O'Reilly Auto Parts, McClendon's Hardware, Home Depot, Lowe's, all kinds of places.
Yeah.
And what I like to do is figure out ways to get things done with stuff that you can find most anywhere.
Mm-hmm.
If it's very difficult to obtain, and I find that I don't have enough, I might be stopped dead in my tracks for weeks at a time trying to get more stuff.
Oh.
So, in order to avoid delays like that, I figure out ways to do things with common materials.
Ah. Have you ever been totally stumped by a material that you needed and you simply just could not, just nothing you could think of existed to do what you wanted it to do? Or even a better question than that, have you ever created something out of an amalgamation of things you would have never thought would have done what you needed it to do, and then you like invented this new material that could be useful in model making?
To the first question, no, because the answer to the second question is I've come up with some of the craziest work building solutions I've ever heard of. If I tell other people about them, there's no way that could work. And I just think to myself, well, you keep thinking that I'm not being able to do that job, and I'll keep thinking I can do that, and I'll continue to get that type of work and get work that you can't do.
Can you give an example of one of those things?
Well, there was, let's see, we did a wind tunnel model for Raytheon one time, and when a project like that begins, you get, they call it a CAD file, computer automated design, computer assisted design, however, whatever CAD stands for. You get a model, a computer model, that just has the outer skin of the aircraft. There are no parts to it other than just the outer layer. And you have to take that and break it up into chunks that you can make and that you can take to a wind tunnel and pull together. And when they designed this model, nobody thought that they were going to run a whole bunch of pressure sensor tubes out through the back of it until we tried to put all these pressure sensor tubes in there and they wouldn't fit because there was no place for them to go. So the engineers from Raytheon said, we need this fixed, and we need it fixed by tomorrow because we have to run this model tomorrow. And we were right in the middle of moving our shop from one building to another. So luckily we had this one small machine that was plugged into the wall and was running, and I had a computer on a shop table. I was looking at this model and looking at it, thinking, okay, how am I going to do this? And so on one side, I got a hand grinder, and I dug this big channel in the aluminum, probably about 6 or 7 inches long, about an inch wide, maybe 3/4 of an inch deep, And I looked at it, I thought, okay, yeah, they'll all fit in there. But I sure don't want to do that on the other side. Be,
Cut it in
I could use
half.
this, be nice if I could use this automatic machine. So I figured out how to do that and hold it on the machine uh, and machine the parts. But that doesn't really answer the weird material question very well. That just kind of answers
That's a weird methodology.
yeah, just uh, how quickly can I get this done and safely? And I ended up machining the other side of the model for the other set of pressure tubes and made a little bracket to hold them in place. And the next day, the guys from Raytheon showed up to get their parts. And they looked and like, that's not enough, that's not enough. They're not going to fit. And I said, yeah, they will. No, they won't. No, they won't fit. Yeah, they will. Go try it. And so they went and tried it and came back later on that day and like, yeah, you're right. They all fit.
That's amazing.
It was, and that was just done at night after hours in a machine shop that was in total disarray because we were right in the middle of moving it, so nothing was organized yet. The weird materials that I've used to pull parts, probably the strangest thing that I could tell a machinist about and really make them scratch their heads on how that would work would be painter's tape and hot glue and particle board.
How did that work?
Well, I covered the cut part with painter's tape because I wanted to bond something to it, but I didn't want to put it right on the material because it was this foam stuff that if you put anything directly on it and then try to remove it, you're going to rip chunks out of the surface that you just made.
Yep.
So I covered it with painter's tape, and then I used hot glue and wood to glue a support structure to the part so that I could turn it over and cut the other side. And then when I was done, I peeled out as much of the tape as I could, and the stuff that wouldn't come out because of the glue and the wood, I just put alcohol on it. And the alcohol is really good at getting in between surfaces. And so it got in between the wood and the glue and the glue and the tape. And it wasn't too much longer before everything came off. And then I just cleaned everything up with a little bit more alcohol.
Wow.
And it was a big piece of plastic that turned out to be fairly thin wall on both sides. So the support structure had to be good enough to support everything when it got turned over, but easy enough to get out that it wouldn't take longer to put it in and take it out than it did actually make the part.
That's pretty cool. Have you ever had an instance where something you tried, I'm sure everybody has, something you tried just didn't work, or it actually caused damage to what you were doing?
Yeah, I was making a big plastic part, and it was 1 foot square, 2 inches thick, and I had it mounted in a machine, and a little voice in my head, when I started, said, no, you should get some sandpaper and some super glue and glue the sandpaper to the jaws on the vise that's holding the material to give it more grip. And I decided not to do that. And then as I'm cutting the part, the plastic starts to lift up out of the vise, and then it's kind of dancing on top of the vise, making this rattling sound, and then it begins to spin around on the end of the cutting tool, kind of like an airplane propeller.
Oh my gosh.
But it was really off balance. And just as I'm turning everything off, everything got really quiet, and I noticed I was sitting on the floor.
Oh my god.
And the piece of material had come out of the machine and pinned my arm up against my side and broke 2 fingers and broke the bones of my arm into, I'm not sure how many pieces, but it was more than 20. And so they took me to Harborview, where the doctor took, well, first he got rid of all the damaged material, which was a lot of muscles and bones and whatnot, and screwed me back together with 3 titanium plates, and I'm not sure how many screws. And then once they were satisfied that everything was in the right shape for what they wanted to do, they transplanted a muscle from my leg to my arm and a bunch of skin in the form of skin grafts to cover it up. And so I have a mostly functional arm. It's got limitations, but I still have a hand, which, had I been somewhere else in the country, I might not be able to say that.
Really?
They may have just taken me into the hospital and said, oh, wow, that's a partial amputation and a lot of destruction. We're just going to have to finish the job, and all your friends will call you Stumpy.
Mm.
But I met a world-famous doctor at Harborview who put me back together. And actually, when my grandson was born, a few years later, about 9 years later, the day we were taking him and my daughter home from the hospital, one of the nurses kept looking at me. She kept saying, I want to say I've seen that arm somewhere before. And in fact, it's that arm right there. She said, I think I've seen that somewhere before. I don't remember where it was. She was watching the University of Washington channel on cable, and they had a special on transplant surgeries. And I was one of the case studies for that TV show.
No kidding.
And so that's where she recognized my arm from.
That's amazing.
And, but that's the worst thing that's ever happened to me, because something went wrong.
Yeah. How did you get back on the horse, as it were? I mean, that's unthinkably traumatic.
Well, I knew why it had happened. I knew that it was my fault, and that had I not performed the operation like that, everything would have worked out like it was supposed to. I've wanted to make parts as a machinist since I was a small child. And so it wasn't that difficult for me to decide that, I'm going to continue my career in manufacturing and just try to be a little smarter about it as I go to work and do my thing. And I understand that most every accident where people get hurt in the work environment is not some really random, actual, true accident like lightning hit the building when there was no warning or anything like that. Most every industrial accident is the result of somebody not thinking things through, or if they did think things through, not executing their plan. Most times, industrial accidents involve one hand destroying the other. When people hit themselves with a hammer or stab themselves with a knife, that kind of thing. If people aren't so lucky, they actually end up hurting one of their coworkers because of poor planning. And so it wasn't that difficult for me to understand that I did this to myself.
Yeah.
And not going back into the career field was never really a choice for me. It's kind of like when a motorcyclist crashes their motorcycle, and I said, "Oh, well, really messed that up. I guess I won't do that anymore." And then they get back on the motorcycle and keep going, or fix their motorcycle and get back on and keep going.
Right.
But it wasn't a difficult decision for me to make.
Ah, yeah. I can see that. One more question, Charlie.
Yeah.
If you, what do you want to leave in your work? Do you want to leave a legacy in your career and in your life as far as your work is concerned? And if so, what would that be?
I'm not too terribly concerned with trying to leave a legacy where people will say, "Oh, look, that's Charlie Gary. Isn't he great?" Um, that that idea, that thought doesn't really strike me as something that I want to be remembered for. The legacy that I want to leave is to teach as many people as possible how I do what I do,
Hmm.
and make sure that if somebody wants to get into manufacturing or model making, that the career is out there for them because enough people do it that people will continue to have it done in the United States and not take it to another country.
Hmm.
It's a great way to make money if you enjoy building stuff. And if people strive to be better than their peers, they can't help but come up higher. Can you still hear me?
I can. It's a little scratchy on the visual, but I can still hear you.
Okay, sorry, there's a message telling me that the Skype is trying to get the call back.
Oh, I'm
But
still here.
okay, well, there's something you can edit out. But the legacy that I want to leave is more people knowing how to do what I do and being able to do it than when I started to do it. You need just in the side of manufacturing jobs going away
Yeah.
to do. And I do that by working with a couple of different technical colleges on their advisory councils. I do stuff with high school kids that want to build robots and compete. Pretty soon I'll be trying to work with the principal of an elementary school. My plan is to get a robotics program started there at the elementary school so kids can get an early head start
Cool.
on the technology stuff in life.
Very cool.
So that's the legacy I would like to create is
Yeah.
some type of educational stuff where as many people as possible can be exposed to
Got it.
to what goes on in life.
Charlie, thank
Yeah.
you. I appreciate that you sharing all that.
Certainly.